Hi everybody, my name is Hong-Quan, from the Information Technology Institute, Vietnam National University. For ACOMP 2021, I am here to present our work, Evaluation of UNET and its variants in solving upper gastrointestinal endoscopy segmentation. Our presentation today includes 4 parts. I first introduce the problem of upper gastrointestinal endoscopy segmentation, and highlight our main contributions in Part 1. Second, we review related works, especially those based on UNET architectures. These methods have been applied to solve the problem of segmentation in the different range of medical imaging. We explain our collected dataset and our experiments in Part 3. A number of experiments are conducted to provide baseline result for this particular problem and to point out the best suitable model. Some issues and potential improvements when applying the model in real-time configuration have also been analyzed there. Finally, we draw the conclusion and state our future study in Part 4.
Currently, the application of AI in medical imaging to support diagnosis is a hot topic that attracts many businesses and organizations. Go deeply, image-based tasks can be broadly divided into 3 groups based on their different objectives. First is detection. It is how to detect potential abnormalities within images. Second is the problem of classification. There we try to classify the input images into multiple predefined categories. Last but not least, it is segmentation, how to define the boundary extent of an abnormality in the input images. This problem will be our focus in the work. Our research subject is upper gastrointestinal endoscopy images. Upper GI endoscopy is a medical procedure that uses a scope to look inside the upper part of the digestive system. It helps assess gastrointestinal damage, especially evaluate gastroesophageal reflux disease complications, or GERD in a short form, which is now an increasingly common disease of the digestive system. It is worth noting that if the lesion is segmented automatically, it can improve the treatment decision of the specialist. Yes, this is segmentation. Depending on the extent of the symptoms, the specialists can categorize the severity of gastroesophageal reflux disease into 5 types: Grade A, Grade B, Grade C, Grade D, and no damage, according to the most widely Los Angeles classification system. To do so, segmentation is the first, but most important step. We agree that if the segmentation is good, then the diagnosis will be accurate, and the treatment will be effective. Therefore, in this study, we only focus on the segmentation step, and our goal is to develop a module that is able to segment lesions automatically to help doctors in their diagnosis. In short, we summarize our 2 main contributions. Firstly, since a dataset of upper GI endoscopy images is not popular in research community, especially those related to gastroesophageal reflux disease, we will collect and label an own dataset of upper GI endoscopy. This is an important basis for conducting experiments not only within this work. Secondly, this work concentrates on UNET model and its variants including attention UNET, R-UNET, R2-UNET, and UNET and plus. Through experiments, we evaluate the obtained results not only on segmentation accuracy, but also on training time and average prediction time to indicate the most suitable model for the problem of upper gastrointestinal endoscopy segmentation in supporting the diagnosis and treatment of gastroesophageal reflux disease. Let's move on to the Part 2. In this part, we introduce some of our related works. As you can see in this table, a number of deep learning-based models have been proposed in the research community to solve the problem of segmentation. Generally speaking, they can be divided into the following groups. 1. Models based on fully convolutional networks, FCN. 2. Models based on pyramid-based architecture, such as PSPNet, Feature Pyramid Network, FPN. 3. Models based on dilated convolution architecture, such as DeepLab 3+, and last but not least, 4. Models based on encoder-decoder architecture UNet. UNet is one of the first deep learning models applied to the medical image segmentation problem, developed in 2015. At the time of its inception, the model was considered effective because it was capable of solving well-known problems with a small set of input data. Another advantage of the model is that it is relatively simple and easy to deploy. Since then, many proposals to improve UNet have been studied. Prominent variants of UNet include Attention UNet in 2018, RUNet in 2018, R2 UNet in 2018, and UNet and Plus in 2020. They are applied in different medical domains. We realize that while there are not many research works in the field of gastroenterology, to best of my knowledge, there are not yet comparatively evaluations of UNet and its prominent variants in segmentation of upper GI endoscopy.
This exactly motivates us to this study. UNet is a simple architecture, and its success in neuronal structures segmentation opens a possibility of obtaining other achievements. For further reading, I highly recommend here the paper of Endoscopy in 2021. They have written an informative survey of research papers in 3 major publishers, IEEE, Springer, and Elsevier from 2017 onward that utilize UNet and its variants for medical image analysis ranging from CT, ultrasound, MR, photoacoustic tomography, endoscopy, electron microscope, to mention but a few.
Again, it is remarkable noting that different from Endoscopy's work, our work is not a survey. It applies UNet and its variants to solve a particular segmentation problem, that is upper gastrointestinal endoscopy. Now in this next part, I am presenting our experiments in detail and provide discussions. Experimental datasets for the problem were collected from a number of different sources such as hospitals and some websites. We have obtained 688 images and divide them into 3 parts according to the 8:1:1 ratio: training set, validation set, and testing set. Data augmentation will be applied in all our experiments. Thus, by adding slightly modified copies of already existing images, the amount of data is increased 8 times. Our dataset is publicly available to download and use for study and research purpose. For labeling these images, we have asked several gastroesophageal specialists for some helps. Lesions in the upper gastrointestinal tract are diverse, such as ulceration, inflammation, circumferential esophageal erosion, or tearing. In the work, we aim to study on semantic segmentation, thus any lesion due to the impact of gastroesophageal reflux disease is considered with only one label. In the endoscopy, the affected areas may be scattered. For example, some areas with ulcers will be discontinuous, so we will evaluate the results according to the IOU ratio, intersection over union. Another name is the Jacquard index. This evaluation metric commonly used in object detection and segmentation challenges. The IOU is the ratio of the overlapping area of ground truth and predicted area to the total area. If GT is the ground truth segment and the SR is the predicted result, the IOU is given by the equation 5. we see that, if the prediction is completely matched the ground truth area, IOU equals 1. The lower the IOU, the worse the prediction result. The IOU score equals 0.5 is considered a positive prediction. Based on IOU index, we also define an IOU loss function in the equation 6. It will be used to evaluate the model training process. The training model with minimum validation error will be saved. We build 5 models: UNet, Attention UNet, RUNet, R2 UNet, and UNet, and on our collected data set. Deep learning models normally require large computational configuration. Thus, to conduct experiments, we use Google Colab Model Training Service. We also set up the same hyperparameters to all models. From the experimental results, it can be seen that Attention Gate has actually brought improvements to the UNet model, and in fact, the predictive performance of the Attention UNet model is the best among the 5 models, with 0.90 IOU points, a good segmentation result overall. Another noteworthy point is that the Attention UNet model has an exceptionally large training size, number of parameters, only behind R2 UNet, but the training time is relatively fast, and more importantly, the average prediction is 0.0548 sec/image. It is the third fastest after UNet and Plus, which are 2 models with far less parameters. If we look at the segmentation results in images, it can explain why Attention UNet and R2 UNet are 2 models that give the most accurate prediction results. They segment enough regions with correct separation between regions. However, the problem of R2 UNet is that some regions has too complex polygonal structure, for example image 4 to 6, which leads to the fact that IOU result of R2 UNet model is lower than Attention UNet. Is this model fast enough to apply in real-time scenario? If the expected result is 25 FPS, the same as the original video, the prediction time should reach 0.0214 seconds/image. It is obvious that all 5 experimented models do not meet this expectation. The current fastest model is UNet, which takes a prediction time of 0.0389 seconds/image. In conclusion, we summarize what we have obtained. First, the work has collected and labeled a data set of 688 upper gastrointestinal endoscopy images, which related to GERD. Second, different experiments in solving upper gastrointestinal endoscopy semantic segmentation have been conducted, and performance comparisons of UNet, Attention UNet, RUNet, R2 UNet, and UNet and models have been analyzed. Third, the obtained results show that deep learning methods based on UNet architecture are able to make good predictions, especially Attention UNet and R2 UNet.
Finally, the segmentation predictions time needs improvements to accelerate video processing, or progress to real-time processing.
Well, we expect that baseline benchmarks obtained on the dataset will provide an opportunity for researchers to continue contributing to the field of automatic endoscopic diagnostic. And in future works, we aim to expand our work to complete a GERD classification in which segmentation of upper gastrointestinal endoscopy is just the first step in the diagnosis.
That's the end of my presentation. Thank you so much for listening. If you have further questions, I am willing to answer, and please feel free to contact me via email.